Okay, so what do you picture when you hear the word engineer? If it's just someone in a lab crunching numbers, well, you're in for a surprise. In this explainer, we are going to completely tear down that myth. We're going to show you the creative, sometimes messy, and deeply human process that engineers actually use to build our world. So let's pull back the curtain on what engineering design is really all about.
And this quote, man, it just nails it, doesn't it? It gets right to the heart of everything. Engineering isn't just about figuring things out, it's a powerful act of creation. It's about dreaming up what's possible and then piece by piece making it real.
All right, so here's our game plan. First, we'll dive into what the design process actually looks like. Then, we'll see how limits or constraints actually spark creativity. After that, we'll figure out how to measure what success really means, learn from some pretty epic failures, and finally, look at how you manage the whole shebang. Okay, section 1. Probably the number one myth about engineering design is that it's this clean, straight line from A to B. But the truth? Oh, it's so much more dynamic and interesting than that. You've probably seen a diagram like this in a textbook, right? Step 1, step 2, step 3, super neat and tidy. But here's the thing, that's not how it works. Not really. In the real world, an engineer tests a prototype, it fails spectacularly, and they jump right back to square two, brainstorming. It's not a line, it's a constant loop. And that loop has a name. It's called an iterative process. It's all about repeating and refining. And here's the absolute key. Failure isn't a bug, it's a feature. It's not the end of the road, it's just data. It's the signal that tells you, okay, loop back around and try something new. All right, so if engineering is all about this loop of trial and error, where does the creativity come in? I mean, we usually think of creativity as, total freedom, a blank canvas. But for an engineer, the exact opposite is true. The real creative magic happens when you're cornered, when you have to solve a tough problem within a bunch of really strict limits. This chart does a fantastic job of breaking it down. Think about it. An artist often starts with a feeling, a shape, they work outside in. But an engineer, they have to start with a specific need. This thing has to do X. They work inside out, starting with a function and building everything else around it. For them, those constraints aren't annoying roadblocks, they are the literal starting point of the entire puzzle. And when we say constraints, we're not just talking about technical stuff like how much power can it use. No, it's way bigger than that. It's about money, it's about safety, it's about ethics. Can you even build this thing in a factory? What happens when it gets thrown out? Is it safe for people? These are all crucial parts of the design problem. So with all these competing factors, how do you even know if a design is a success? It's not as simple as just asking, hey, does it turn on? The real measure of a great design is way bigger than that. It's about the entire life of the thing you've created. All right, I've got a question for you. Take a look at these two light bulbs. Which one's the cheaper choice? I mean, the one that costs less to buy, right? Seems obvious. Well, check this out. The cheap 60-cent bulb, over its lifetime, it's going to cost you 57 bucks. Why? Because it burns out fast and it guzzles electricity. Now, that $5 bulb, the total cost is less than $18. Crazy, right? The upfront cost was totally misleading. There's a name for this, and it's a super important concept in engineering. Life cycle cost, LCC for short. It means looking at the entire picture, from the cost to buy it, to the cost to run it, all the way to the cost to get rid of it. A truly great design doesn't just have a low price tag on day one. It delivers value across its entire lifespan. But, sometimes things don't succeed. And honestly, that's when some of the biggest lessons are learned. Let's dig into a couple of famous cases where the design process went seriously wrong. First up, we're jumping back to 1994, the Intel Pentium bug. And this is a story that's not really about bad code. It's about breaking trust. So here's what happened. A tiny bug in the chip would very, very rarely cause errors in some really complex math. Intel knew about it, but they kind of brushed it off as no big deal. Well, the public found out, and the backlash was immediate and massive, forcing them to recall everything. See, the takeaway here wasn't about the math error. The real failure, the catastrophic failure, was in underestimating how much customers value honesty and trust. All right, for our next story, let's head back to the 70s and the brand new BART transit system in the San Francisco Bay Area. This one is all about professional responsibility. So you have these three engineers, and they're looking at this new, shiny, automated control system, and they're thinking, wait a minute, this hasn't been tested enough. This isn't safe. Their bosses told them to be quiet, so they went public. They ended up getting fired for it, but their actions drove home a core principle of engineering. Your number one duty is to protect the public. That comes before your company, before your boss, before anything. So, okay, we've got this messy, creative, iterative loop, and we've got these huge ethical stakes. How on earth do you manage a project like that? Well, it turns out that how you manage the plan is a huge design decision all on its own.
On one side, you have the waterfall method. It's very linear. You do step A, finish it completely, then move to step B. This is perfect for something that's not going to change, like building a city's power substation. You know the requirements up front. But then you have Agile. That's all about loops and flexibility. It's for projects that are going to evolve, like designing a new charging circuit for a phone, where the tech is changing by the week. One isn't better than the other. They're just the right tool for the right job.
All right, so after going through all of that, the loops, the constraints, the failures, the plans, let's come back to where we started. What is engineering design really? Well, we know what it's not. It's not just a calculator and a rule book. It's a creative process. It's a non-stop loop of trial and error. It is the art of finding an elegant, beautiful solution inside a tangled mess of constraints. And above all else, it's a human-centered and ethical responsibility. It is, truly, about creating the world that has never been. So now you know the real story behind it all, the messy, creative, human process. And that leaves me with just one question for you. Take a look around your own world. What problem, what little annoyance or big challenge is just waiting for a design?